Hi, what I'm going to do today is Introduction to Pythagorean Identities. Let's start off with reviewing the Pythagorean theorem. This is capital A, capital B, capital C in triangle ABC. Opposite the A, small b, small c. So what we can say is a squared plus b squared is equal to c squared. The Pythagorean theorem. Well, let's work with the rules in algebra. Whatever you do to one side of the equation, you have to do to the other side of the equation. So if I divide both sides by c squared, let's look what I'm left with. A squared over c squared plus b squared over c squared is equal to 1. And if I can work this out, I can say a over c squared plus b over c squared is equal to 1. Now let's look at the relationship that we have here. Well, a over c opposite over the hypotenuse happens to be sine. So let's call this sine a squared plus b over c is cosine a squared is equal to 1. And you're going to see that this is mostly written as sine plus cosine squared equals 1. Let me show you what it's not. Sine a squared plus cosine a squared means you're raising a to the second power. So you will never, ever write it like this. This is the way it's written. This, the second power by the sine a, is telling you take the sine a, the entire function, and you raise that to the second power. Let's just prove it by using the simple example that we all know. We're going to say, let's pretend that a happens to be 30 degrees. Okay, so if this is 30 degrees, let's look at what we know. We know sine of 30 is half. Cosine of 30 equals square root of 3 over 2. So let's look at what this is. Sine squared 30 plus cosine squared 30 is equal to 1. Well, sine of 30 is half, so I'm going to say half to the second power plus square root of 3 over 2 to the second power. Is that equal to 1? 1/4 plus 3/4 is equal to 1. 1 is equal to 1. So it does work. This is the simplest of Pythagorean identities. And of course, if we said sine squared a plus cosine squared a is equal to 1, we can say sine squared a is equal to 1 minus cosine squared a, and cosine squared a is equal to 1 minus sine squared a. That's the first of 3 Pythagorean identities. Let's look at another one. Let's look at the Pythagorean theorem again. A squared plus b squared equals c squared. And again, I'm just going to draw it for you. I'm saying a, b, c. Instead of dividing everything by c squared, let's divide everything by a squared. And let's see what happens. Well, if that's the case, we have a squared over a squared plus b squared over a squared equals c squared over a squared. Well, 1 plus b over a squared equals c over a squared. So 1 plus, well, b over a happens to be cotangent. So cotangent squared of a is equal to c over a, which happens to be cosecant squared over a. So right here we have another identity. Of course, we can say cotangent squared A is equal cosecant squared A minus 1. Again, using some simple algebra. Okay, instead of me just doing it for you, try the next one on your own, put it on pause, and divide everything by b squared and see what happens. And you develop the concept. Okay, now hopefully I'm going to take a breath, wait for you to come back, and then we'll go over it. Okay, welcome back. Let's try it again. A squared plus b squared equals c squared. This time around I'm going to divide everything by b squared. Both sides of the equation. So let's look at what we have. A over b squared plus b squared over b squared, which is 1, is equal to c squared over b squared, which is c over b squared. Now let's look at the relationship here. A over b, opposite over adjacent, we know is tangent squared of angle A. Plus 1 is equal to c over b, which happens to be secant squared of A. And now we're finished. And we can also say then, tangent squared of A is equal to secant squared of A minus 1. With that, that's the introduction to the Pythagorean identities. Thank you.